Hello everyone, this is Chapter 8, Consumer Mathematics, and this is the very first section, 8.1, Percents, Taxes, and Inflation. This whole chapter is going to be about a variety of different math problems that deal with basically money, financial math. And here in 8.1 we're going to get an introduction to percents essentially. Some of this is pretty basic, some of this is review, that's fine, so let's just cruise through it. Percent comes from the Latin percentum, which just means per 100. So all a percent really is you're taking a quantity and you're splitting it up into 100 pieces and seeing how much of that 100 you have. So if you take the fraction 1/4, for example, that means out of 4 pieces you have one of them, right? So you've split something up into 4 pieces and you've taken one of those pieces. Well, 1/4 is, if we just deal with fractions, it's the same thing as 25 over 100. Right, but now 25 over 100, you're saying I've split this thing into 100 pieces and I have 25 of those pieces. Well, by definition, that is a percent. All a percent is splitting something up into 100 pieces and figuring out how many you have. So we could say that 1/4 is the same thing as 25 over 100, which is a percent right there. That's just the same thing as 25%. So percent just means per 100. Alright, so I'm just going to go through a quick review on how to convert from percents, decimals, and fractions, and back and forth. So we're going to start with percents and decimals because these are the easiest. It just amounts to either moving the decimal twice to the right or twice to the left. So we're going to start with percent to decimal. If you have a percent and you want to convert it to a decimal, all you have to do is take the decimal point, wherever it is in the percent, and move it twice to the left. Here's your two examples. We got 17.45%. We have a percent, and our goal is to convert it to a decimal. So all we're going to do is take that decimal point and move it twice to the left. It'll end up in front of the 1. We'll put a 0 out front just to make it look nice. So 0.1745. It's no longer a percent, now it's a decimal, but they stand for the same number. Same thing down here at the bottom. We have 0.05%. We have a percent, we want a decimal. No matter where that decimal is, we move it twice to the left. Notice we're opening up a 0 over here, so we're going to have 0.0005. Very similar to the last one, same idea. This time we have decimal to percent, so we're going to move the decimal twice to the right this time. We have 2.45, this is a decimal. We want to convert it to a percent, so we're going to take the decimal and move it twice to the right. So we get 245%. It's okay to have percents that are over 100%. Our next one, 0.025, just a decimal. We want to convert it to a percent. Take your decimal place, move it twice to the right. We end up with 2.5%. Fraction to percent, we're going to multiply it by 100. This is technically what we're doing with a decimal as well, if you think about it, because multiplying by 100 just means you're going to move the decimal twice to the right. So it really is the same thing, we're just multiplying it by 100. So in this case, if we have the fraction 2/5, we want to convert it to a percent, so we're going to multiply it by 100. This is just 100 over 1, right? So you're going to have 2 times 100, which is 200, over 5 times 1, which is 5. This is now a percent. As soon as you multiply by 100, it becomes a percent, but obviously you should reduce the fraction if you can. 200 over 5 is 40, so we get 40%. And then percent to fraction, remember percent means per 100, so we're basically just going to divide it by 100, or put whatever your percent is over 100. So 14% by definition means 14 per 100. And then you just need to reduce it, right? They both have a 2 in common. If you divide them both by 2, you get 7 over 50. And that's it. Okay, so now that we know how to convert back and forth between fractions, percents, and decimals, the whole point of that exercise, by the way, is that you never want to do arithmetic with percents. You always want to convert your percents to either decimals or fractions. And in practice, most people don't like to deal with fractions if they don't have to, so we'll probably just be converting our percents to decimals. Now we're going to be solving some basic equations and then some word problems we're going to be solving some basic problems and word problems involving percents, and we're going to use what's called the percent equation. So the percent equation just says you take the percents, you multiply it by some base, and you get some amount. The challenge of these word problems is going to be figuring out which of these pieces do I have and which piece do I want. So there are 3 things in this equation. So at any given time you can be given 2 and be asked to find the third. So I have this little phrase down here, we take percents of bases, to help you figure out which piece is which. The percent is always the easy part to find. It either has a percent on it, right, or it says what percent, which means that's the part you're supposed to find. Now, if you think percents of bases, that means the number that comes after the percent. So it might say, if I'm 50% of 30. Well, as soon as you see this percent of a number, that number is going to be the base. So that's why I want you to remember this phrase, we take percents of bases. So in the word problem, look for the percent, look for the of, and that number that comes after the of will always be your base in this equation. And that just means whatever the remaining quantity is, that's going to be your amount, most likely. Alright, so let's use this percent equation to solve this basic little problem here. So it says, what is 15% of 60? Well, right here I see my percent and my of. That means that must be the base. So in our percent equation, it was percent times base equals amount. That means our third quantity here, which is the what, this is what we're trying to find. We can just call that x. So we have everything we need. I'll write the percent equation one more time for you. Percent times base equals amount. Okay, so our percent is 15%. Remember, you never do arithmetic with percents, so let's go ahead and convert it to a decimal. It'll be 0.15. We're going to multiply this by the base, and since we take percents of bases, I know that 60 is the base. And the amount is what we're trying to find. We're just going to call that x. Kind of did some bad form here, right? We shouldn't mix our x's with multiplication symbols. How about we do the dot for now? There we go. So now x is just whatever 0.15 times 60 is. And if you throw that in the calculator or do it the long way, doesn't matter, you should get 9. So x equals 9. So it turns out that 9 is 15% of 60. Alright, same idea. This time we're missing a different value. So we have 63 is 18% of what number? There's my percent, there's my of. That means we're solving for the base. So the base is going to be x in our equation. So remember the percent equation, it's percent, which we're going to use a 0.18, times the base, which is what we're actually solving for in this problem, so we'll call it x, equals the amount. Our third quantity over here is just the 63, that's going to be our amount. So 0.18 times what equals 63? Well, we can solve this with basic algebra, just dividing both sides by 0.18. They cancel out, and if you throw this in the calculator, you will get 350. So there you go. 63 is 18% of 350. Okay, and then lastly, this is our third option, right? This time we're missing the percent part. So what percent means our x, I'll just put that underneath here, our x is going to be what we're solving for, which is going to be a percent in this case. But we still have percent of a base. So we still don't know which one's the base, and that still also means our 288 is our amount. So in our formula, it'll be percent times, so our percent is an x, I'll use a dot for times, our base, which is 640, equals the amount, the other number we have. All right, and then solve this for x, divide by 640, both sides. Those cancel out, and we get x equals, again, I would just throw this in the calculator, you'll get 0.45. But remember, this is kind of where people forget to do this very last step. X was a percent, and we just got 0.45. Our job is to turn this into a percent. So we're going to move the decimal twice to the right. So this is actually 45%. Right, so 288 is 45% of 640. Okay, so that's covered the kind of basic equations, or sorry, basic problems that don't have any context, right? Just what percent is what of what. Now we're going to kind of tie it in with some word problems. So in your book from page 386, we're going to do number 34. It says, in a certain year, DiGiorno sold $478.3 million worth of frozen pizzas. If total frozen pizza sales were $2,844.8 million, that's a lot, what percent of frozen pizza sales was due to DiGiorno? Usually the hardest part of word problems is just kind of getting over all the information they gave you and trying to figure out what's important. So always try to focus in on the question. So what is the question in this problem? Well, the question is, what percent of frozen pizza sales was due to DiGiorno? Well, that's good because they have our percent of base right there, right? What percent means we're solving for the percent, so that's going to be our x, of frozen pizza sales. Well, that means frozen pizza sales is our base, right? Because we take percents of bases. Now, frozen pizza sales, if you look back in the problem, says DiGiorno sold 478.3 million. If total frozen pizza sales were this big number. So when they say what percent of frozen pizza sales, I'm assuming they mean the total, which is that 2,844.8 million. That's the value that will be our base. And then lastly, was due to DiGiorno. We know that DiGiorno sold 478.3 million, so that will be our amount. Okay. So let's back up. We'll start with our percent equation, which is percent times base equals amount. Our percent is x, because remember it asks us what percent, which means we're solving for the percent. Of frozen pizza sales, that means we're going to multiply this by our base, which is frozen pizza sales, and that's total frozen pizza sales, which is the 2,844.8. And our answer just being millions, so, well, actually we're solving for a percent, so it doesn't matter, but we don't need the million. So that's percent times base equals the amount, which is the was due to DiGiorno. Well, 478.3 million, oops, is our amount due to DiGiorno. 478.3. So there we go. That's all this problem is really boiling down to, is what percent of 2,844.8 is 478.3. Calculator work after we do our one algebra step, dividing both sides by this number. Cancel out x equals. Don't forget we're solving for a percent. So the first thing is, obviously we're not going to get a terribly pretty number. We're going to get some decimal out of this. We'll call it 0.1681. I'm just taking, I know that I'm going to move the decimal twice to the right, so I want to have 2 decimal places left over. There's no specific instructions here, so make sure you follow the rules that my math lab says, because they're picky. So we have a decimal, move the decimal twice to the right to make a percent. 1, 2. So we'll get 16.81%. Right, so what percent of frozen pizza sales? It turns out 16.81% of all the frozen pizza sales in the country, we're assuming, was due to DiGiorno. That's the question we just answered. Okay, next problem, page 386 still. We're going to do number 42. This one has to do with a little chart here. So take a second to figure out what this chart is trying to tell us. It says, this is titled Top Websites of 2012. At the bottom we have a list of different websites, Facebook, Google, YouTube, etc. And on the left it says millions of visitors. So I think what this should mean is in the year 2012, Facebook had about 700 million visitors, or Google had 900 million visitors, something like that. So our problem over here is asking what percent of the total visitors to these sites was due to Facebook and YouTube combined. Notice what percent of total visitors to these sites. That's our percent times base, and that means our amount is going to be Facebook and YouTube combined. So first of all, what percent means we're solving for percent, so that's going to be our x. Of the total visitors, well, we're not given that directly, but we can find that out pretty easily, right? Total visitors will be the sum of the heights of all these bars, right? So real quick, total visitors, can't spell right now. Total visitors is what you get if you add 700 to 900 to 450, 350, and 500. And if I did my math right, you should get 2,900. This is in millions, by the way, so it's 2,900 million visitors total. And then it says was due to Facebook and YouTube combined, so let's just calculate that. Facebook plus YouTube That is, Facebook is 700, YouTube is 450, so that should be 1150, 1150. Okay, and then we can set up our equation. Remember, percent times base equals amount. So when it says what percent of the total visitors, that means what percent times the total visitors, which is our base, which is 2,900, was due to Facebook and YouTube combined. There we go. Divide both sides by 2,900. Cancels out here. Let me get some extra space real quick. And we get x equals decimal first, obviously rounding it. So x is about equal to 0.3966. And since we need a percent here, that's 39.66%. So what did we just figure out? According to this data from 2012, 39% of all the visitors to these 5 pretty popular sites, about 40% essentially of all the visitors were for Facebook and YouTube combined, right? A big chunk of it. That's what we figured out. Okay, and we're going to do some more percent problems. This one's going to involve a formula called the percent change formula. Sometimes you see this as 2 different formulas, the percent of decrease formula or the percent of increase formula. I call it percent change because it'll do both. The only thing you have to keep in mind is decreasing is going to show you a negative number. So if you follow this formula and they ask you for the percent of decrease, you might get something like negative 0.3, which would be a negative 30%. Well, you don't want to enter the answer as negative. You want to say it decreased by 30%. So a negative number is going to basically inform you that it was a decrease versus a positive number, which would inform you that it's an increase. Okay, so let's use it. On page 386, we're going to tackle number 38. Number 38 says, in 1991, the price of mailing a 1-ounce letter was 29 cents, and by 2010, the cost was 44 cents. What was the percent of increase? Well, that's a very nice specific question. Whenever it asks you what is the percent of increase or the percent of decrease, we're going to use that formula that we just discussed. So the percent of increase, I'm going to abbreviate. It equals the new amount minus the original amount, all divided by the original amount. So in our case, what is the new amount? Well, we go from 1991 to 2010. 2010, the cost was 44 cents, so let's put 44. Notice you could put 0.44. In this case, my answer is going to be my values are in cents. It's actually not going to matter because we're going to get a percent anyway, either way. So it actually doesn't matter if you use decimals or not. I'm just going to call it 44 cents. My units are cents here. Minus the original, which was 29 cents in 1991, and you divide it by the original, which is 29 cents. So on top you subtract, you get 15 over 29. Now think about it. We want a percent out of this. Right now we have a fraction. Our rules essentially were to multiply by 100 if you want a percent. So if you multiply this by 100, you get 1500 over 29%. And you might as well just throw that in the calculator and get a decimal and round it because that's not a very useful number here. This is about equal to, it's 0.5172, so that should be 51.72%. That is the percent of increase. So what we're saying is when the price went from 29 to 44 over these 19 years or so, it increased by about 51%. What that means is that it increased by a little bit more than half, right? So if you think about it, 29 is about 30, half of 30 is 15, and see how when we go from 44 to 29, that's a jump of 15 cents. So that's what they're saying. They're saying the amount of increase, which was 15 cents, is about half of what it originally was. Or in this case, it's a little bit more than half of what it originally was. So that's what it means. That's how you find a percent of increase. Okay, another problem involving percent of increase. This one's a little bit different though because they give us the percent. So it says, according to the U.S. Bureau of the Census, from 2000 to 2007, the average price of a new home in the U.S. increased by 51.5%. They're giving us a percent of increase. Right? So it increased to 314,000. That would be our new amount. To the nearest thousand, what was the average price of a new home in 2000? So remember, 2000 to 2007 it increased. So when they give us the 314,000, that's the amount in 2007. They're asking us for the amount in 2000, which would be the original amount, right? So think back to our percent equation. 51.5% is our percent of increase. So I'm going to plug it in as 0.515. Be careful about that because if you plug it in as 51.5, you've already made it a percent, which means you kind of have to throw another times 100 on the other side of the equation. It's kind of a mess. So just get in the habit of never ever doing arithmetic with percents. Anytime you plug it into the equation, you immediately make it a decimal or a fraction. So 51.5% is 0.515 as a decimal. So our percent of increase equals new amount, which is 314,000. We'll just use 314. Minus the original amount, which is what we're after, right? Because the original amount in this case is the amount in 2000. And it's divided by the original amount. Alright, so again, let me just point this out to you. Percent of increase equals new amount, which is the amount in 2007, which is 314,000, minus the original amount, which is the amount in 2000, which is what we're after, divided by the original amount, again, the amount in 2000. So this is a pretty basic equation. If we want to solve it for x, the first thing we should do is get x out of the denominator, which means we're going to multiply both sides by x. Oh no. Hold on. No. There we go. Sorry about that. So we're multiplying both sides by x. There we go. The x's over here cancel out. So over here we get 0.515x equals, the x is canceled out, so we still have 314 minus x on top. Good. So now we need to get all of our x's onto one side. So, doing too much of this. Okay. So we need to move this x on the right to the left. So we're going to add x here, add x here. Here the x's cancel out. Over here we have 1x essentially. You can think of the invisible one there. 1x plus 0.515x's, that'll be literally 1.515 x's. We're just adding the numbers in front of them. And over here we'll get 314. And then lastly, if you want to solve for x, divide both sides by 1.515. Cancels out here, and you should get x equals, this is a percent by the way, so I think we're going to get a decimal first. Oh, I'm sorry, this isn't a percent. This is the amount in 2000. So our number will be about, get my squiggly equals, about equal to 207,000. We'll round it to. And this is money, of course, so $207,000. So it was $207,000. It increased 51.5% to 314,000. So this amount here that we got was the amount in 2000, the original amount. Still on page 386, let's tackle number 36. This one says, according to the U.S. Bureau of the Census, 2007, the average price of a new home was 314,000. By 2010, the price had dropped 13.1%. So if it drops by a percent, that's decreasing by a percent. To the nearest thousand, what was the average price of a new home in 2010? So this time they're giving us the new amount, the 314,000. They're giving us the original amount, which is 314,000. They're telling us it decreased by a percent, 13.1, and they want us to find the new decreased amount, essentially. So we can do it with the same formula, but like I said, since we're given a percent of decrease, we have to plug it in as a negative. So that 13.1% we're going to call negative 0.131. That is our percent of decrease. Now on the other side, we're going to have the new amount. Well, that's the amount in 2010. That's what we're solving for. So that will be x minus the original amount. So they told us in 2007, which is our starting year, the amount was 314,000. Notice this kind of picks up from the last problem. and we divide it by the original amount again. And there we go. So now if you want to solve this, you can start again by multiplying both sides by 314. Kind of out of room over here. 314. There we go. Here they cancel out. On the other side, you have a negative 0.131 times 314. I got about, I'll go ahead and just take the whole number for now, negative 41.134 equals x minus 314. There you go. And now if you want to solve for x, all you have to do is just add 314 to both sides. Cancel out here, and over here you get x equals about 272.87. This is money, so I decided to round it to 2 decimal places. And this is in thousands of dollars technically, so it's I should put 1,000 down here. So when the housing dropped by 2010, it dropped by 13.1%, and in 2010 the average price of a home was now 272,000. Yeah, it would be $272,87,000. There we go. Okay, that's that. All right, and then the last type of problem we have to do here is just it's pretty basic. We're just going to use kind of one of these tables to calculate an income tax. So this is from page 384, example 9. Says this table is taken from the instructions for filling out form 1040 to compute the federal income tax for a single person. So let's kind of skip the table for a second, jump down to part A. It says if J is unmarried and has a taxable income of $41,458, what is the amount of federal income tax she owes? So the way this this table works is, depending on what your income is, you fit into different brackets. So as you can see, they've already kind of highlighted line 3. It says if your taxable income is over 30,650. Well, ours is 41,458, so it's over this, but not over 74,000. We'll see how ours isn't over 74,000. Clearly we fit in this bracket, so that's why we're following line 3. So it says the tax is 4,220 plus 25% of some amount. So the first thing is these numbers here, these are all flat rates that if you're in this bracket, automatically you're paying this. So let's throw that into our computation. So far we know that the tax is going to be 4,220 plus, now it says 25% of, and in the next one it says of the amount over, and then in our line it would be the amount over 30,650. So if it's going to be 25% of something, we can write that as 0.25 times, and then that's something. So the something is the amount over 30,650. So to figure out the amount over that, we would take our income, the 41,000, I'll go ahead and write it, 41,458, and subtract off 30,650. Okay, so check this out. This is, if you just kind of follow that line, it says, well, obviously we're in this bracket here, and it says the tax is 4,220 plus 25% of the amount over 30,650. That's what this calculates. This is our income minus that number. That would get us the amount left over, or the amount over 30,650. Right, and so then from here it's just throwing it into the calculator. Oops, let me do 4,220 plus 25% times. The difference there will actually end up being, sorry, I had it here, 10,808. That is the amount over 30,650. And then when you multiply it by the 0.25, you will get 2,702. And then lastly, add these two numbers together. You should get 6,922. Alright, so according to this table, a unmarried person that had a taxable income of $41,458 would end up paying income tax of $6,922, according to this table. So that's it. That's it for this section. Let me know if you have any questions, and keep up the good work.